Okay, so this is Properties of Exponents worksheet number 26. Says 2x to the fourth, y to the negative fourth, z to the negative third, all over 3x squared, y to the negative third, and z to the fourth. Okay, so again, remember that I said there's more than one way, more than one order to apply the properties and still be doing it correctly, right? So what I'm going to show you is just one of those ways. First, I'm starting with the 2 and the 3 on the top and the bottom. 2/3 cannot be reduced, so those are going to stay as they are. Now, it looks like I have a bunch of quotient rule or quotient property here. I have x's, I have y's, and I have z's. And I'm dividing with the same base, right? So I apply the quotient rule in each case. X to the fourth over x squared. I subtract the exponents. 4 minus 2 is 2, so I get x squared. Y to the negative fourth divided by y to the negative third. Subtract the exponents. So negative 4 minus negative 3 is the same as negative 4 plus 3, which comes out to be negative 1. So I would write y to the negative 1, but then I know I need to flip it to the bottom because it's a negative exponent. So let me take this down to the bottom. Y to the first, which I don't need to write the exponent of a 1. Then we go to our z's. Z to the negative third divided by z to the fourth. So negative 3 minus 4 is negative 7. So I end up with z to the negative 7th. But again, that has a negative exponent, so I'm going to flip it to the bottom. So I'll take that away and put z to the positive 7 on the bottom. And that's my answer. All right, next, number 7, 2y squared times 3x. So I'll start with the coefficients, the 2 and the 3. Multiply those together to get 6. Y squared and x, they do not have the same base, so we cannot multiply them together. It's kind of standard procedure to put variables in alphabetical order. X comes before y, so we would say x, y squared. And we're done. Number 9 is 4a cubed b squared times 3a to the negative fourth b to the negative third. Okay, so we're obviously multiplying, right? So we should be thinking product property in our head. But we'll start with the coefficients. The 4 times the 3 would give me 12. Then I'll have the a's, and then I'll have the b's, right? So a cubed times a to the negative fourth. I add the exponents. 3 plus negative 4 is negative 1. So I end up with a to the negative 1. B squared times b to the negative third. Add the exponents. End up b to the negative 1. Now I recognize that I have 2 negative exponents. So I need to flip those to the bottom. So you think of this as being over 1. Leave the 12 up top because it has its own exponent of a 1. Move the a to the negative 1 to the bottom where it would become a to the positive 1, and b to the negative 1 to the bottom where it would become b to the positive 1. And there's our answer. Number 28, 2h to the third, j to the negative third, k to the fourth, all over 3jk. Okay, so we're obviously dividing now. So I'm thinking quotient property. I'll start with the coefficients, the 2 and the 3. Again, 2/3 cannot be reduced, so we just, leave that alone. Now I don't have any other h except for right there. So there's nothing to do with that. So I'll just keep the h to the third right there. Next, I have the j's. So I'm going to apply the quotient property there. J to the negative third divided by j to the first. I subtract the exponents, right? So negative 3 minus 1 is negative 4. So I would have j to the negative 4. But that's a negative exponent, so I'm going to flip it down to the bottom. So j to the positive 4 on the bottom. And then I deal with the k's. K to the fourth divided by k to the first. Well, 4 minus 1 is 3, so I have k to the third up top.